Artificial intelligence is transforming nearly every business, as you heard from Kathy just 30 minutes ago. Now, it can be very hard sometimes to understand how AI is actually going to transform my business or your business. It is hard to sometimes understand how to practically use AI to make decisions. And over the last 10 years, when I look back, I got an amazing opportunity to work with, help build organizations that leveraged AI. And now I get to work with many companies that are transitioning or stepping into an AI-powered world. So in the next 20 minutes, I hope to show you what AI-enabled organizations look like and how you can use AI in your businesses. So my journey started about 10 years ago. I grew up in a small city in India, and growing up, I was excited about a few things. One of the most exciting things for me at the time was airplanes and rockets, and I used to learn about those things in Britannica magazines and Britannica books in the libraries and popular science and mechanics books. Like that was the only resource I had growing up in schools. And I was very determined that I would want to go and pursue a career designing airplanes and rockets. And that led me to come to Silicon Valley. This was just in the last maybe 8 to 10 years. And coming to Silicon Valley, I had an amazing opportunity to not just pursue my career in aerospace engineering, but also meet a lot of people who fundamentally were optimists in the world. And so many of the people you see are from Singularity University. I participated in that in 2012. Right after my graduation from Stanford University, I was very determined to participate in building tech companies. And at that time, there were few frontier technologies that I saw from my vantage point, and I was ready to participate in that. One of the first ones was Drone Deploy. Drone Deploy actually is a tech company that was started by 3 South African friends who moved from here to Silicon Valley and got venture-backed funding and started that. Now, in 2012, drones were not a thing. People would only think of drones as something that government uses. And in actually the last 6 years, drones have basically went mainstream. The company enables commercials like farmers, constructions, mining companies to use drones for capturing aerial insights. And it is an amazing feat that within 5 to 6 years, the technology was not in the hands of people, and now everyone uses it for making daily decisions. Soon after that, I spent there about 4 years. Soon after that, I went to Planet Labs, which is another exciting company that I admired since college times. Planet Labs has over 200 satellites that orbit in a low Earth orbit, and it images the entire Earth every single day. So imagine Google Maps updating every single day. We downloaded 7 terabytes of data from these constellation of satellites. And by the way, these satellites are like shoebox size and cost maybe like $150,000 to manufacture and a small amount to get it into the orbit. And you might think like, hey, how is all this related to finance and to the other aspects of the world? Well, let me show you. At the company, with all the data that we captured, I saw firsthand how we were able to capture very unique insights that was powering businesses around the world. Here's an example. We used AI to essentially count number of cars from these satellite images around the parking lots. And with that, we knew that Walmarts or Home Depots around the country, what times, how much traffic they saw. And that insight, hedge fund managers or macro funds would use to make decisions before their quarterly earnings. pretty wild. Like imagine knowing everything about the retail economy that happens around the world, and all of the data is actually available. You can just see it from the low Earth orbit. And this was my first large-scale glimpse of or experience of seeing AI in action at such a large global data set. So that's an example one. Second thing, we also, because we can see so much, basically everything from space, we could also measure how much how much oil there is reserved around the world. Now it's pretty cool because all the oil reserves kind of looks like this, and the roof floats over the oil. So if the storage are empty, you can see some of the like moon-like shadow, and AI could learn essentially how all of these storage around the world, how filled were they, and based on that, we were able to create indexes that would feed companies around the world on the global oil supply. Now, these decisions, like in like 10, 20 years ago, they would literally be humans looking at these images and kind of capturing insights to make decisions. Now, this is all automated. You just train an AI that scans all these images and gives you like an indicator. You never really see like there's a whole marvel engineering behind the scenes. Now, this is actually one of my favorite use cases that I get to build and see firsthand, which is essentially predicting global production of ag commodities. Now, again, we are imaging the planet Earth every single day, so that also means that when ag season comes in, we know how farmers, how their patterns of growth are, where they're growing corn, wheat, soy, and every plant has a unique signature of what their health looks like. So based on that, we could basically see the entire Earth, how much production there might be in this ag season. And this information is actually really useful for the largest buyers of corn, which might be like brands like Coca-Cola, who needs to plan way ahead in time where to make smarter investments. Now, all of these experiences made me realize that the world is changing at an incredibly fast rate, and this is my experiences of seeing AI in action, and it really kind of made me realize that there is a big undercurrent underway, and to kind of really understand like what really is changing and what the pace of this change is. Let's kind of take a step back and see the history of compute. This is an earliest form of computation, and this is a Chinese abacus, and this is one of the first times where humans started to build a tool to compute simple problems. Now, fast forward that to the 19th century. Fast forward that to the 19th century, and Charles Babbage made a difference engine. This was, again, made for simple computation for adding and subtracting. And this was largely based on mechanics. So people would design gears, and they would think about like how each gear configuration might result into an answer. Then we moved to digital substrate using transistors, capacitors, etc. This is an ENIAC, which was one of the first general-purpose computer. This shift also led to what we are very familiar with, software 1.0. Everything that you see around us is largely built with software 1.0 methodology, which is essentially you take a very large problem and you kind of break it down to smaller chunks of those problems. Like, hey, if I'm building a solution, what are the 5 mini solutions that needs to work together to provide a product or service to audience? And of course, then you work with a team of human programmers. You write algorithms to solve each of those problems. And then, of course, the last step is to kind of glue all of this together. You use Amazon stacks or Google Cloud Compute, et cetera. There's just hundreds and thousands of services that go in to make a software work. And this has actually got us really far. We have gone to the moon. We have also gone to Mars in a robotic world. And all of the world that you see is largely powered by Software 1.0. Now, AI is different. AI is fundamentally changing all of this. And what I call that is essentially Software 2.0. Now, why that what is the fundamental difference in Software 1 and 2? Well, the biggest difference is that now human programmers are not needed to come up with logic or deconstruct a problem. What really has happened in the last 5 years is that we have now this thing called deep neural networks, which essentially is, think of this as a module in a software. And of course, there is some science behind it, et cetera, but it is essentially a dumb system. But turns out if you feed it with a labeled data, it learns nearly anything you want it to teach. And you don't have to know about how you're going to solve a problem. You only have to think about what you're going to teach computer, what are you going to teach this neural net about, and magically things work. So this is really fascinating because now we are changing essentially like from thinking about problems and solutions to kind of like, hey, this is the problem I want to solve, and I'm going to use a neural net and feed it with a lot of data that hopefully will learn and make those decisions. So here's an example. In Software 1.0, I would take, let's say if I'm solving a problem, this is a sonogram. If I want to detect a set of features, I might have a software team that would essentially go through all the permutations and all the things that could go wrong, or all the attributes of a feature, and probably like think through that in logical sense. Like, hey, this is what a feature looks like, or this is what a feature doesn't look like. It's a very arduous process. And you might build a software that would detect it, but it might be very brittle because it doesn't generalize over a lot of domains. In Software 2.0, you take the same set of data, but now you essentially have humans teach a neural net. Like, hey, neural net, I want you to learn about this feature. And if I send that a lot of times to the neural net, it would essentially begin to learn. It's kind of like how you teach child with experiences. And in Software 2.0, this is actually the architecture that most of the AI-enabled organizations are using, implementing, or leveraging to drastically improve their products and services. What it really looks like is essentially you're feeding a lot of data to these neural nets. These neural nets are making decisions, and sometimes they would make bad decisions, so you won't want to have a human team review them, correct them, and then continue that process. So essentially, Software 2.0 is a nice confluence between humans and AI, and humans teaching AI to always make the right decisions. This is pretty exciting because now you don't really need a lot of software chops to solve some of the biggest problems on Earth. What this also means is you can solve problems like this, detecting certain features in sonogram, and scale it around the world, and you're only limited by compute and data. Otherwise, in Software 1.0 world, you're really scaling humans around the world to provide those insights with some support from computers. One of the things that happens in Software 2.0 is essentially, I think Kathy alluded to that, is training data. Like in self-driving cars, for instance, you can't really design algorithms that would take care of every permutation. So what you're really trying to do is just collect as much data as you possibly can, and then expose that to neural nets so that they kind of learn to handle those cases. And with that, my point being here is that with all of this, label training data is essentially the new gold for every organization as they step into the world of AI. And what this also means is that if you aren't thinking about what is your proprietary data sets in your organizations and how you're going to convert those data sets into labeled data sets that you can use to construct a software 2.0 architecture, you're likely missing out at the biggest innovation that is happening around the world. What is also really exciting to see is there are new class of tools emerging to teach AI, because now you're really just teaching an AI in the form of data. So here's an example where if you wanted to have an AI learn to detect defects on solar panels or clouds in the imagery, you're just really telling it like, hey AI, this is how a defect looks like, and this is what clouds look like, and you do it quite a few times, and AI just learns. Similarly, on the right side, you see a tool that is used to teach an AI for classifying a conversation between a call operator and a customer. And you're really just teaching like, hey, this conversation is relevant, and others might be irrelevant. Now, this is a major shift from how we used to solve these problems in Software 1.0. Like, it would take decades of research or effort to have computers come to these answers. But now you just simply use these neural nets and feed it with a lot of data. Now, with all the things that you saw, there's even more exciting things exciting news for all of us. These neural nets are increasing their efficiency at an amazing rate. So if you take in account GPU innovation as well as the software algorithms or the algorithms of neural nets, the effective doubling rate is 3 to 5 months, which is insane. Like 5 years ago, computer vision didn't really work. And now we are in a world where you have seen some of the tech, I think in the earlier conversations with facial recognition, self-driving cars. Like the technology is moving at an unprecedented rate that we've never seen before. I believe like that's like 300,000 x increase or so in the effective compute of AI algorithms over the 5 or 6 years. Not only that, the cost of computation is decreasing, which continues to decrease, obviously, with the Moore's law. And so think about now that all these neural nets are not only getting better, but they're also getting cheaper. Also, they're ultra scalable. So imagine a world where trillions of these mini brains are embedded in all the appliances and all the world that we kind of just take it granted it works. But now they can be in intelligent systems. They can learn more about yourself. They can interact with you. And you can train them or personalize them how you want it to work. And this is all essentially limited by compute and data. So compute obviously is being solved by a lot of, with the trends. So it really boils down to data. And this is what I mean about AI-enabled organizations. When you think about companies that are making products and services largely by AI, you're really thinking about these models that are making decisions on behalf of your organization. And these models are learning from the data that your organization has and the expertise, the human expertise that works with these AI models to teach them to make better decisions. And every organization has lots of data in raw format, images, text, video, audio, and some combination of that. And what you have to think about is how are you going to use that data and convert it into labeled data sets that you can use to solve problems in your businesses. Lastly, I want to leave you with a thought of what are some of the kind of key takeaways that you can kind of think about today to explore using AI in your businesses. Well, first is, while AI is very transformative and is a very exciting area, it requires a lot of trial and error, and it still requires a lot of investment from your team to be focused on solving problems with the new technology. And the biggest advice I can give you all is that define a very narrow problem that has high ROI in your business. And once you define a very narrow problem, that also enables you to really think hard about what are the kind of core decisions that currently your organization makes that could be augmented with AI. And you have to have some time horizon where there would be a world where the AI models will be working in conjunction with humans to improve the decisions before it totally takes over. But that's okay. That's how most of the technologies are. Second thing is collect the relevant data that is useful to solve that problem. And as you saw, data is the king for the world of AI. And third is think about how you're going to use that data, how you're going to apply human perception on that data sets to convert it into training data, which is essentially what these algorithms use. And there may be very smart ways. In Facebook, for example, we just tag our friends, and we are essentially feeding training data for algorithms to just get better and better and better. That is actually one of the ideal ways for you to create applications where your customers are training your algorithms, consciously or subconsciously. But there are many other ways that you can also collect training data sets in your products and services. And that is going to be a big factor for you to rapidly accelerate your AI advancement. And the lastly is training AI models are not elusive anymore. All of these neural nets are available as modules that are in hands of developers. So if you have a developer team, they're likely to be able to build AI models and power your decision making in the business. And the key thing is to keep iterating and not stop until you solve that problem. Thank you.